So perhaps we can start. So good morning, everyone. Most of you know me because we've been having a lot of discussions on CCUS, and I got all of you here, which is quite exciting. My name is Alissa Park. I'm a faculty member in Earth and Environmental Engineering and Chemical Engineering at Columbia University, and also Associate Director of the LEMFES Center for Sustainable Energy. And I'm the PI of this grant funded out of NSF, National Science Foundation in the United States. And this particular program is called RCN, Research Coordination Network, which is kind of a unique program within NSF. And this is themed around the CCUS, which I'm going to talk about a little bit. So when I started looking into the solicitation about 2 years ago on RCN, what they were really looking for is these keywords. Communication, coordination, training, educational activities across the discipline, organizational, geographic, and international boundaries. All sounds very interesting and nice, right? And I think in a way that we do that quite often when we go to international conferences. As a faculty members, we do that a lot. But at the same time, when we talk about new research field, we still do what we do all the time without going too much far away from where we are comfortable. And although we talk about it at the conference quite often, still each conferences we go to, we meet our peers, not the people who we are never really work with, right? So then I think that kind of bring to me that frustration of that there are a lot of research questions we need to ask in the area of carbon management, which we can't answer just with one discipline, and that's where we started. And particularly at LEMFES Center for Sustainable Energy, we've been asking these questions with a lot of colleagues in different disciplines. And I think that's the unique part of Columbia University because we are highly interconnected through Earth Institute, that there's a law school, CIPA, which is School of International and Public Affairs, and Engineering and Science, all coming together and ask a lot of these questions together. But we really didn't have means to actually do things with outside Columbia as much. So why and how and where we came from and then why we are interested in CCUS. This is one of the latest reports from IPCC. A lot of people talked about yesterday, and we had a really successful workshop as a part of RCN yesterday talking about air capture. And without going into too much details, and a lot of us are engineers in the field, in this area, at least we can kind of take home the message. I think this was a summary for policymakers. And that here it says, we need substantial multi-century climate change commitment created by past, present, and future emissions of CO2. A lot of times when we talk about CCS, we talk about how to reduce emissions, which is like a current thing, right? But when we look at this statement, basically we already emitted so much that not only we need to reduce our emission, but we have to take care of what we did in the past and what we're going to do in the future, so that it has to be really long-term commitment and looking at the broader picture. And that takes a lot of effort, for sure. So just looking at the technology itself, I'm not going to go into too much detail on who does what and what are the schemes available. We're going to talk about it a little bit. But this RCN is not trying to talk about what is the winning technology, not selecting one, or try to say this is a better approach than the other. More talking about where are we and where should go from now. And when you look at the CO2 capture, you can capture from point sources, or like what we discussed yesterday, entire day, that we can capture CO2 from air. And any source we have with high concentration CO2, we should tap into. Because our final goal, hopefully everybody's working on the fact that minimize CO2 concentration in the atmosphere, right? And its consequences in climate change and so on. So that people start to work in this field about 20 years ago significantly, I believe. And I think I've been in this field about 10 years or so, a little over 10 years. And that once you capture it, they decide that, well, maybe we can inject into geological formations. It could be under the deep sea bed, or you can do it even on geological sequestration inland. We've been working on this area for many years, and a lot of our know-how we learned from what we did with EOR, enhanced oil recovery, and so on. Now, after that, people start saying that, well, you can do EOR or enhance the methane recovery or inject into geologic formation, but we can also convert to something else. Myself and some of my colleagues been working on how to solidify CO2. So you might pay upfront a lot more energy penalty at the beginning, but maybe we have a lot less problem with monitoring and long-term commitment of ensuring that area and all that so on. Or some people also claim that we can convert CO2 to some other materials, fuels, chemicals, and we talked about that a little bit yesterday as well. As long as we have carbon-free energy, you can go back up the energy field, no problem, so we can definitely do that. So by looking at all these, definitely there are more than one pathways for us to remove CO2 from atmosphere, or at least increase the efficiency so that we don't need to emit more CO2. So I think when this field started, it was called carbon sequestration. That was a new word I had to learn like 15 years ago or so. Then we went to CCS, carbon capture and storage, right? And for a long time we did use that, and I think about 2010 or so we started using CCUS. And that utilization can be interpreted in many different ways. In the United States, I think the most viable, or what people are mostly talking about, is EOR, enhanced oil recovery. But rest of the world, and also a lot of faculty members, my colleagues, are working on making chemicals and fuels. And I think a long-term futuristic view, that's not really so bad, because for us, we live in a carbon-heavy society. No matter what we do, replacing all the electricity with carbon-free energy, renewables, we still need to deal with carbon somehow in material flow. So then being able to manipulate these carbon-use materials back and forth with maximum energy and materials extraction as possible with minimum environmental input has to be everybody's goal in a way. So having said that, I went back and then my student did a quick search on Google Scholar, so this may not be perfect, but we searched for any papers had CO2 capture, storage, utilization, conversion, exact words, so it's not really capturing everything, but at least getting some picture of it. Apparently, our field is not that old. I'm sure a lot of people study this area in a different way. For example, I guess mineral carbonation didn't start until later, about here, 2000 or so. But there were a lot of people looked into mineral weathering for many years in the natural science. So a lot of literatures are there, but not in the goal of CCUS. So at the beginning, most of the publication, although very little, were on the storage, and then quickly capture took off after 2000 or so, and now we are making almost 4,500 papers per year in this field. And if you look at these two, I did the search for CO2 utilization and conversion. I guess there are many different keywords you can try. It's a lot less, but you can see it start to pick up quite a bit. So there are a lot of people writing or studying, doing research on this area, and we are not even counting all the research is done in the industry. So definitely last 10 years or so, there was a big amount, a lot of effort went into this. So the question I get quite often, and I'm sure many of you get, why don't we do CCS? Why is it not implemented yet? That was the question. And I don't know how you answer it, and I try to answer it as much as I can do. A lot of times the technology developers, like researchers, science and engineering, they usually say, well, until there's a policy in place, this is not going to happen. And I'm sure policy people will answer it that, well, there's no technology which is economically feasible. So how can we have regulation when there's no solution? So when we have two groups like that talking like it, why don't we have everyone in one room and actually talk about where can we start instead of doing catch-22, right? So yeah, so how can we make sure that how policymakers can make it at the same time, technology side can make it at the same time. And not only looking at social science versus the engineering and science, even looking at capture side and storage, these researchers are quite different. They go to different conferences. They don't really share the fundamentals. At the same time, reaction itself is very similar. So, hold on. So when you try to think about how to look at capture and storage, we are really looking at different time scale and spatial scale. And I think that makes it somewhat frustrating. So if you look at here, capture side, most of the engineers, most people working in this technology developments are chemists, mature scientists, or chemical engineers. So we're looking at reactors, and things happens a lot faster. If it is taking longer than half an hour, you might say, well, it's not feasible. At the same time, most people who are working on storage are looking at Earth as a storage tank or reactor. It takes a lot longer time. You have a lot bigger scale to work with. So trying to merge this different time and spatial scale is not as easy as you think. So that is the reason we developed this RCN, and what we really wanted to do, and it's based on my voice and as well as all my colleagues' voice, is that CCUS community, although everybody said it's important, we never really had coherent voice. Everybody thinks that this is really urgent issue. They try to develop the best technology without really thinking how to link everything together. So all our effort becomes making a good solution for whatever scenarios we have. And I think that was very important. So we decide that having this RCN will provide us that area, avenue that we can network with other players in CCUS and then collectively find out what are the right questions to ask and how to answer them together by sharing our expertise. So this is our mission statement we came up with last October when we met together at Columbia with the steering committee members. Our mission is to build a transdisciplinary research coordination network on carbon capture, utilization, and storage that facilitate research collaborations and training that cross the boundaries of the natural science, engineering, and the social and economic sciences to develop this CCUS technology for the not only current, but for the future and long term. So this is the structure of RCN. For those who are not part of RCN, it's open, so whoever wants to join us, please do so. And this is happened, I think, in a way that an involvement of professional engineering society. This is the unique part of our RCN. So led by Darlene Schuster at AICHE, we actually have 5 United States-based professional engineering societies, as well as one from UK, actually joined us. You can actually reach not only the students and faculty members, but we're going to be talking to professional engineers in the young professionals to the seniors who can make decisions in industry, which is really fantastic. We also have a significant educational thrust area. We combined with Pamela Tomsky on the REX program, so we actually go to the field and talking about CCUS. We also, Klaus Lackner is leading making Master's of Carbon Management at Columbia. This is one of the unique programs, and I think a lot of other schools are looking at whether we can make it and then what would be the outcome of that. In the research side, we have 4 thrust areas. Of course, they're very interconnected, but in order to, for others to find out who's in what area, we divided up to 4. So first one is CO2 capture and conversion. Second one is CO2 transportation, storage, and EOR. Basically, the division was, this is mostly chemical reactors, much faster reactions, much smaller in this volume and scale, just because reaction is a lot faster. And this second thrust with the storage and EOR is looking at Earth and how it connects to the Earth in the system. We also have a thrust area on monitoring, verification, and accounting, risk analysis, which is really important for the long-term storage of CO2. And of course, we have policy and business law thrust to work with each other and throughout every discipline of this thrust areas. It was really interesting. This project started only a year and a half. And when we had a first kickoff meeting in February, actually we had our kickoff meeting on Valentine's Day 2013. And a lot of people tuned in globally. And amazingly, we had over 10 countries and more than 100 people joined in. And I was very surprised. And I think this is evident that people have been looking for effort like this to combine people together and talk about what are the real problems are. So what are the activities we have? And we are kind of open to new ideas as well. And this entire grant is trying to do research coordination network. We are not really supporting any new one particular technology. We do research coordinations. We have annual meetings and workshops which you're attending. And we have a lot of webinars which they're archived on our website, so you can take a look. We also do educational one, which we talked about, and a lot of K-12 activities and so on. And those are the current activities. This is our website, and you can take a look at what we've done and what we are thinking of doing, and you can get a lot of information in what's happening in CCUS area.